Okay, here's working on lesson 10, number 1. Without graphing, identify the x-intercepts of the graph. And so I'm looking at my factors here, and I know that wherever it crosses the x-axis is going to be where y is equal to 0. And so what values of x would make this whole thing equal to 0? I know x equals 7 will, and x equals negative 3 will. And then those intercepts would be at the point 7, 0, and negative 3, 0. And just a little bit more on that. If x is 7, then I end up with this. If I plug in 7 for x, and I'd have 0 times 10, which is going to be 0. And again, my y value is going to be 0 at my x-intercepts. And so this value of 7 makes the whole thing equal to 0. So that's going to be an x-intercept. The other one then would be negative 3, because if I plug in negative 3 for x, I would now have negative 10 times 0, which is going to be 0. So again, that is going to be my x-intercept, wherever the y value is equal to 0. In number 2, now I expand it out and multiplied it out, and I get x squared minus 4x minus 21. And so I know that my y-intercept is going to be here at negative 21. Because if x is 0, in those places, I still end up with negative 21 in my function. And I know that whenever x is 0, that's going to be where it crosses the y-axis. Number 2, B is the correct answer here. And that's because if x equals 2, I did that right here, plug in 2 for x, my whole function ends up equaling 0. And if x equals negative 1/2, I did that over here. It makes the second factor equal to 0, so it makes the whole function equal to 0. One other way to look at this, like the second factor here, I'm not sure what x needs to be to make that equal to 0. I can think of that as like its own separate equation. Okay, what does x need to be in that factor to make it equal to 0? And if I solve that, I would get x to be negative 1/2. And so you see that right there. So that's another way to think about it. Think of each factor. What does that factor need to be 0? Okay, in number 3, C is the correct answer here. And I did that by looking at my x-intercepts. And I know that if x is 3, I'm going to have an x-intercept of 3, 0. And if x is negative 1, I'll have an x-intercept of negative 1, 0. And that's what I see happening on the graph right there with those intercepts. Number 6 is a review from earlier in this unit, lesson 7. D is the correct answer there. If this part is predicting how many games it's going to sell, and then P is your price, if you multiply those together, you would get your estimate of your revenue. In number 7, here's what they would all look like, written out in standard form. You could have done a diagram like I did here, or you could do your arrows with your distributive property. I just did number 4 down here because that's the one with slightly bigger numbers. I did it as a diagram, and so you can see there's the 12x squared, where that comes from. And then I would combine these like terms, negative 28x minus 3x, to get my negative 31x. And then there's the 7. And number 10, A is the correct answer here. I know that because my starting value needs to be less than 100. If it was 100 here for F, for G, it looks like it's a lot less. So that rules out C and D. And then my growth factor for G, I know it needs to be greater than the growth factor for F. And I know that because as I keep going here, you can see right about here, they cross, and then from that point on, G is going to have higher values than F. And so my growth factor I know needs to be greater because it eventually crossed and overtook the function F. And so because of that, the answer needs to be A. In problem number 1, B and H are the correct answers. It's kind of nice to break this problem kind of in half, where you look at A through D first with the intercepts. B is the only one that is accurately describing the intercepts here. If x is 0, that's going to be an intercept, and if x is 11, that's going to be an intercept. And then the other half of the choices are dealing with the vertex. And we saw that the x-coordinate of its vertex is going to be halfway between the two intercepts. So halfway from 0 to 11 is 5.5. Okay, looking at problem 2, C and E are the correct answers, and here's why. I'm looking at the x-intercepts, and I know the vertex again, the x-coordinate of the vertex is going to be halfway between my x-intercepts. And so C, I would have intercepts at 1 and 3. So I graph those right there, and I can see that 2 is going to be in the middle of those. E is going to have intercepts at 0 and 4, and I graph those there, and I can see that 2 is going to be in the middle of those. Okay, looking at the table on problem 3, here are the correct answers on the table. And the only one I want to talk about is the middle one with the finding the x-coordinate. It might be easiest if you graph it out. I'm only worried about my x-axis here, and I graphed my intercepts at 4 and -5. And again, I know the x-coordinate of the vertex is going to be halfway in between. And so once I graph it, that's going to be a lot easier to see, or maybe even to draw out how I know it's going to be at -1/2. Okay, number 4, which one is the graph of this function here? And I'm looking at my x-intercepts. I know I'm going to have intercepts at 3, 0 and -5, 0. And the only graph that matches that is graph C. Here's my x-intercept at 3. Here's my x-intercept at -5.